Yep, hi folks. So yeah, so this is the final step for the CIS project. We have been working over 3 months, and this is one of the craziest project have been working. And the as the slide shows, it's the title named blockchain file system. If I have to explain in words, it's using the cloud technology, we are dividing the file into chunks and storing it in the blockchain, so that ensuring the security in the cloud-based fashion using the blockchain technology as well. So talking about the team members, my project partner Saikran Madipadiga and myself, Sharad Bhushan Podila, have been working over the 3 months on this project, and we have made a considerable progress. And uh, yeah, so I'll be walking through different aspects of this project, like motivation and the methodology, the results we have arrived at, the conclusion, and the limitations or the future works we have. So let's get started. So yeah, so the motivation behind is like there are a lot number of the blockchain technologies available in the market. So what makes this project special is I just have listed. So one of such blockchain based file sharing system is IPFS, where which is one of the decentralized solutions for the digital file exchanges. But what makes this project special is the advantage over the IPFS, mainly the immutability, where this project maintains the unmodifiable record of all the file transfers, ensuring the history of file exchanges, and the transparency and the accountability, where any participant in the network can scrutinize and validate the exchange records. And if you move on for the next motivations, right? So the smart contracts, right? Which helps us to develop the file objects that contains the information such as file ID, file name, and the file data. And it basically enforces specific rules for conditions related to file access. And we basically use Solidity smart contracts for developing the file objects, and building it on the Ethereum blockchain based blockchain. So one of the great accessibility this project provides is the integration with the cryptocurrencies. So what it does is it flexibly integrates with cryptocurrencies for providing the users to participate in the network, or for enabling micropayments. So my teammate would take over and explain the technical details and the methodologies we followed. So I can over to you.
Yeah. So, Sharad, do you like to mute yourself? So yeah, coming back to the technical stack. So the technical stack we decided to go with is Angular JS, HTML, CSS, and Bootstrap for the front end. So we designed a simple user interface for the user to upload files and share the files to other users, depending upon their email ID. We have kind of given an abstraction of all the blockchain related terms like public key, private key, and how to connect to the blockchain, and all that is abstracted from the user, so that they share the files with other. They can share the files and upload their own files into the blockchain file system without any hassle of going through the complexities of blockchain. And for the encryption algorithm, this is the most important choice that we made. We, rather than going with a SHA-256 or AES 256 encryption algorithm, we have chosen to go with XHR20 Poly 1305 algorithm, which kind of gives us an advantage of being light and easy to run on smaller machines like uh, our own laptops and MacBooks, because AES takes a lot of computing power to run and encrypt the files. And we have used Keccak 256 to compress the encrypted hash that we get for each file, and put it in smaller chunks. And for interacting with the blockchain, we have made the option. We have gone with Solidity smart contracts, where we wrote Solidity file to do the file transfers and file uploads onto the blockchain. And we have used SQLite as a base database to store user information. This was supposed to be hosted on Azure Cloud, so this makes it a cloud and blockchain based file transfer system. So coming back to our main control flow, how it works is, so when we open the file, open the web app, like we can log in, and we have, after a file after user uploads a file, we are checking if the file is corrupt or not, and it prompts a user to encrypt the file using. So you have to prompt the user to upload the file if file is not uploaded, and if the file is not corrupt, we are going to encrypt the file and upload the file to Azure Cloud, our which is our SQLite database hosted on Azure Cloud. Uh, in fact, it can be any SQL database. It need not be SQLite. It can be Oracle or maybe any SQL Server database. We have gone with the simple choice of SQLite because it was easy to develop with Golang as the backend. So that was one other thing that I think technical we forgot to mention in the technical stack. We are using Golang for the backend, so it is easier to use with Golang. So that is why we went with SQLite. And coming back to the process itself, after uploading it to the database and updating the app database, we are going to upload it to Ethereum blockchain using a smart contract. So how the upload itself works, and how the encryption is done is explained in the next slide. After that, the user gets few options of sharing the file. Basically, he can download the file himself because he's the file owner. He can share it privately to other users based on their email. So he has to know the email of the user to send the or share the files to that particular user. And then he can make it public, which means that it is publicly available on the blockchain, and anyone who wishes to see the transfer of ownership of the files is able to see it. And depending on that option he chooses, we are going to decrypt and download the file and show it to the user. So let's move on to the next slide, where we go through the interface and how it works. Like I said, like we discussed earlier, it is a blockchain communication system. So basically, the front end part is quite simple, where we had to give a login screen, a sign up screen, and provide authentication and authorization. And the login process itself is used on terms of email and password, typical web application authorization and authentication. And where it differs is in the process of uploading file. So we actually did a bit of research where if we upload the entire encrypted file onto the blockchain, it's going to be very, very costly, because uh, the file sizes can be huge. So what we did here is basically we broke the file into sizes of 1 KB chunks, and we encrypted each chunk using XHR20 algorithm. And the resultant hash that we got is again a 1024 byte array, and we compressed that byte array into a 32 byte array, 32 byte array of size 32. So essentially, we compressed the 1 KB file into a 32 byte file, 32 byte chunk, and we encrypted. We compressed it using KECAC 256, and later we kind of maintained a map of the mapping between each block hash for the encrypted chunk. Sorry. So coming back, so this is how the entire file is compressed by a factor of 1024, which is the size of 1 KB chunk. And then we took a smart contract where we established, we basically compiled and uh, you know locally stored application binary interface and bin files for the smart contract, the Solidity smart contract. And what we did here is we established an Ethereum client connection to the Solidity contract, and did a bit of encoding there to establish a secure connection. And we sent the block hashes that we stored, and instead of storing the entire file, now we stored only the block hashes for the 1 KB chunks that we had. So the size of the file is significantly less. And apart from this, the all the block to block encrypted block to the block hashes mapping is stored in the database on the SQLite. So when the user want to view the file or download the file, what happens is the sender request, and if they're authorized, uh, the backend goes back to the smart contract, sees if the user has the enough privileges and access rights to view the file. And what it does is it fetches the block hashes and gives it back to the backend, which is the Go application. And the Go application takes care of fetching all the encrypted blocks, decrypting it using the poly chacha exacha poly algorithm, and combining those blocks into a single file and giving it as a download option to the user so that he can view it locally. So this is how the interaction among the components works, and the user is notified of the transfers if there is a transfer. For example, if I'm a sender and I want to send a file to Sharath, uh, both the owner of the file and the receiver of the file are both notified, depending upon the transfer is successful or not. And so we discussed thoroughly about downloading the file as well. Now I'm handing over to Sharath to discuss about the metrics. Over to you, Sharath.
Yeah, thanks, Saikran, for explaining the entire workflow, what we followed over the project and the methodology we used for the developing the interface, uh, uploading and downloading a file. So obviously, the key takeaways of the project is when you actually show the results in terms of different parameters, or like that will show you the true color of the project, right? So we took a couple of metrics, and we actually compared with the traditional uh, cloud mechanism or the decentralized storage mechanism, that is IPFS, and also the blockchain based cloud file transfer system. And the scalability is where how long to what extent the size can grow, and it can accommodate the data with large chunks of files data that Saikin is talking about, right? So, and also the the scalability is also directly proportional to the number of active users actually operating on the blockchain and the files. So if you could see the metrics, right, we have increased the number of users. For correspondingly, we have calculated the response time for each of the cloud technologies I was speaking about. And the blockchain based average response time was found to be very impressive with the code we have developed. And if you could see the graph as well, right, the blockchain actually gives you the better results with like 0.40 seconds with 1 lakh of users. So I guess it's one of the key takeaways is in terms of scalability. And if you can also go to the next slide, right, it actually talks about the average file transfer, right? Also, like, it depends on since this is basically a file sharing system, we need to talk about how the files are shared using the cloud technology, decentralized technology, and the blockchain technology. So since we are talking about the files, we take the file size into consideration. We took three parameters basically. One is the small size, medium size, and the large files. And if you take the small size of the file, it's basically less than or equal to the 5 MB. Medium files ranges from 5 to 50 MB, and the large files ranges from the greater than 50 MB. Right? We have the metrics, and obviously, if you could see the metrics again, right, the blockchain based cloud technology found to be impressive again, and correspondingly the graph. So even for the average file transfer, it basically stands out of the in competition when it compares to IPFS and the traditional cloud. Also, when we talk about the cloud, when we talk about the Ethereum blockchain, everybody thinks about how much cost the project actually takes. But in terms of cost also, the metrics was found to be impressive, right? So if you have to compare the traditional decentralized and the blockchain based technologies, the blockchain based technology actually cost the lower in terms of in the cost as well. So yeah, so if you take the scalability, average file transfer, and the cost comparison parameters into consideration, I would say the blockchain based technology is one of the impressive project, which includes the blockchain cloud, and which ensures the security with the help of encryption and decryption algorithms. And in conclusion, I would like to say, the blockchain cloud transfer system, it basically presents us the secure and decentralized solution for the digital file exchanges. right? And we have developed this project with different dimensions, like with respect to the client, is he authorized enough to access the cloud technology and the blockchain technology we have developed through the a good web based or the mobile based interface. The upload and download processes were also designed to maximum ensure maximum security by encrypt the files using the advanced algorithms. And like even the files can be shareable among the users. So overall taking into consideration, we have taken into the consideration the a good amount of the options for the users to experience, and also the good amount of security has been promised, right? So but if I have to extend this project, so let me talk about the future works as well. So yeah, so the future works will actually include radar networks, integration of radar networks with the current project we have developed. So what it basically provides is the off-chain payment channel architecture, which creates effective and cost-effective platform for digital file exchanges. And also we can also integrate the smart contract. So what it does is, like, if based on the proper upgrades, we can get the automate dispute resolution, customizable file retention policies, and also the content licensing management. And also, since we talk about mostly the file data, right? So you are also supposed to take care of the file data compression techniques as well. So yeah, so this is about the gist of the project and the future works as well.
One thing I would like to add is that all the metrics that we tested are manual, and most of the scalability part we had to individually do uploads and downloads to test the response times of the systems, and the cost comparison is done in terms of Ethereum. The uh, development ETH that we got, and we converted into the dollar price to make an effective comparison. And also the file transfer. This has been tested by repeatedly uploading and downloading the files. That would be all. Thank you so much.